Yesterday we had talked about how to find a limit as x approached a value using tables and by looking at a graph. Today we're going to talk about another method, and that is going to be using direct substitution. And direct substitution is generally quicker and yield the same result. We need to make sure the function is continuous, and that means we can use substitution to find that limit. And we just need to know that it's continuous where we want to find the limit at. Yesterday we had those weird looking graphs that had portions that were continuous, but they weren't continuous where we wanted to take that limit. Direct substitution generally will be more difficult for those piecewise functions where you have those lines going in different directions like this, or this is another type of piecewise function. So for those, you really probably need to graph those and see what's going on. Now, I've just said the word continuous a few times, and a continuous function or a continuous interval means that you can sketch it without lifting up your pencil. All polynomials are continuous functions. So example 1, 4x squared plus 3, we know that's a quadratic, so the graph is a parabola, and we know that we can draw that without lifting up our pencil, so that is always continuous. So to find the limit, we are going to substitute in, we're going to substitute in 2 for x. So 2 squared is 4, 4 times 4 is 16, plus 3 is 19. So the limit as x approaches 2 of 4x squared plus 3 is equal to 19. And we could confirm that graphically too, just to make sure, but sometimes you're asked to do these limits without the aid of a graphing calculator, so using direct substitution would be the best method for those. Then we have example 2 here. This is a cubic function, another type of polynomial that we know is continuous. So substituting in -3. -3 to the third is -27, plus -3 squared is +9 times 4 is 36, then minus 11. So -27 plus 36 minus 11 is going to give us -2. So the limit as x approaches -3 of x to the third plus 4x squared minus 11 is equal to -2. So life is really easy when we can just directly substitute those values in. But as we saw with some of the problems yesterday, substitution may not have been the best solution or may not have worked at all. Like this one right here, we can't substitute in +2 in this example 1. So one of the techniques we can do is we can rewrite this as a different equivalent function where we can substitute in that value. So what I mean by that is this one right here. We can rewrite this in factored form on the numerator. X squared plus x minus 6 factors to x plus 3 times x minus 2, and that's all over x plus 3. So these two cancel. So this is really equivalent to the limit as x approaches -3 of x, we don't need parentheses, of x minus 2. So x approaches -3 of x minus 2. We can now substitute in -3. We do -3 minus 2 is -5. So the limit as x approaches -3 of our function here, x squared plus x minus 6 over x plus 3 is equal to -5. So again, we weren't able to substitute in -3 to the original function, but by factoring and reducing, we could get an equivalent form that allowed us to plug in -3, and we got that value of -5 when we did that. So the limit of the original function and this equivalent form is equal to -5. Now we could have done that for this problem up here. We could have factored the numerator and then canceled off the common factor, and that would have allowed us to plug into, but the table method also worked. All right, now example 4, we can't substitute in 0 because that gives us a 0 in the denominator. We can't factor the numerator. So what we're going to do is we're going to be using the rationalization technique. Normally we rationalize the denominator, but for this one, our radicals in the numerator, so we're going to multiply the top and bottom by the conjugate x plus 1 over x plus 1 plus 1. So we're using the conjugate of the numerator. And again, remember, we use the conjugate because it eliminates that middle term. We use the conjugate, we just have to multiply the first terms. So the square root of x plus 1 times the square root of x plus 1 is just x plus 1. And then we can multiply the last two terms. -1 plus 1 gives us -1. And that is going to be over. You might be tempted to try to distribute that, but trying to distribute that inside the radical just makes life a lot more difficult. So we leave it like this. We're going to combine like terms in the numerator. We have x plus 1 minus 1, so that's just going to be x over x times the square root of x plus 1 plus 1. Well, we have an x in the numerator and denominator, so those cancel. So when we cancel everything off in the numerator, there's an invisible 1 that goes there. And then in the denominator, we're left with x plus 1 plus 1. So now we rewrote that as a different form of this function that allows us to substitute in 0. So the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1 is equal to 1 over the square root of 0 plus 1 plus 1. Well, this 0 plus 1 gives you 1. The square root of 1 is 1 plus 2 gives you 1/2. So that means the limit of the original function, so the limit as x approaches 0 of that original function, the square root of x plus 1 minus 1 over x, is equal to positive 1/2. So we call that the rationalizing technique. It is a little more tedious, and there are opportunities for algebra errors, but if you don't have a calculator with you or allowed to use one that can graph, this method is what you would have to do. All right, so on to the next page, I want you to try these three. All right, so letter C is another rationalizing one. So I'm going to give you the hint to multiply the top and bottom by x plus 1 plus 2 over the square root of x plus 1 plus 2. And you want to multiply out the numerator but leave the denominator alone. and then something will happen where you can cancel out the x minus 3. So go ahead, pause the video, and try this, and then once you're done, unpause it, and we can see how you did. All right, so here are your answers. Hopefully A and B weren't too difficult when looking at letter A. We would just have to substitute that value in. There wasn't anything else that you really needed to do for that, and you get -5. Letter B, you had to factor out the x from the denominator, and then once you factored out the x from the denominator, that allowed you to substitute in 0 for x, and you're able to see that the limit is -1. And then letter C is the one, again, like I said, you had to rationalize. So again, when you rationalize the numerator, the first two things being multiplied, x plus the square root of x plus 1 times the square root of x plus 1 is just x plus 1. And then -2 times +2 is -4. And then when you combine the like terms in the numerator, you can cancel out that x minus 3 factor in the denominator, which then allows you to plug in +3 for x and get that the limit is 1/4. So today's lesson was about substituting in your x value for the limit if possible, and if it's not possible, some strategies you could use. Now, if neither of these strategies work, factoring and cancel and then rationalizing, then you may have to turn to a graph. And if you can't use a graphing calculator, you're going to have to use algebra when substituting in values and see what do you approach. Okay? So thanks for watching. Make sure to like and subscribe.